can record it now. We start talking about trigonometric form of a complex number. Trig form of a complex number. Trig form, in the other words, is called polar form. Trig form of a complex number or polar form, it's the same thing. There will be synonyms. And this is something which we started working with yesterday. So let me remind a bit that every complex number could be graphed in a complex plane. Let me put z. Z could be denoted as a complex number. And let's say z is a plus bi, where bi is the imaginary part. So let me write this as imaginary part. Imaginary part. When you graph it on a complex plane, the horizontal, the usual x-axis is real number, and the vertical, the y-axis, is imaginary number. So imagine I would like to graph z equal, I'm just making something up, let's call it 3 plus 2i. Or let's call it z1. And if I would like to express it as a point on the complex plane, I will go 3 units to the right, 1, 2, 3, and I will go 2 units up, 1 and 2. And that's how you can graph a complex number. Let's call it z1. Very similar to what we've done before. Oh, please write this down. Every complex number could be characterized by modulus and angle. So this is just the new term modulus, but I think you already know what modulus means. So let me call that to be r, and you will tell me what it is. That's called modulus, but this is something familiar to you, which has just other term. How do we call this? Magnitude. So modulus and magnitude, they are synonyms. I don't know why do we have different terms in math, but it is what it is. So whenever you say the word modulus, think about magnitude. Which means every complex number could be written in the form. Let's say you have, let's work with the z1. z1 was 3 plus 2i. So this will be rectangular form, something which we practiced in Delta Math yesterday. This is called rectangular form. Rectangular form. But you can also express it in polar or trigonometric form. So let me do it one more time. You go 3 units to the right and you go 2 units up. Will be 2i. And if I would like to express it in polar form, what do I need to know about this? Magnitude and an angle. Very good. So let me find magnitude very quickly. Magnitude z1, or you can also call it r1 in some textbooks. And now our Larson Precalc textbook, it's called r. Maybe it's denoted as radius, but what it means is really magnitude. Tell me what number is that? 2 squared plus 3 squared. How much is it? Root 13. So this is the magnitude, and we also need the angle. And angle will be theta. Theta will be arc tangent of 2 over 3. I have no calculator, but you guys know how to do that. Some number. And then you can write that z1 could be expressed as root 13, comma, and, yeah, anyone knows the number? 34? Thank you very much. Let it be that way. So we discussed how to convert rectangular to polar, and you practice that in Delta Math. That should be familiar to you. Now, how to go from what? So I did now polar to rectangular. Now polar to rectangular, which is even simpler. Polar to rectangular. Imagine you have some number in polar form, which has magnitude of r, or modulus of r, and the vertical change is always r times what? If this is angle theta, to find the vertical change, I will multiply by what? Sine or cosine? Vertical. Sine, and to find horizontal, it will be r cosine. Which means I can express my, let's call it maybe Z2, just to make it different. Z2 will then have polar form, r times cosine theta plus, well, since vertical change is imaginary, I times r times sine theta. Also, we discussed this already. That's really the same thing we're talking about, with just implementing different terms. If you wish, you can also factor radius out. And in about a couple of minutes, I will tell you why are we going from polar to rectangle and backwards. So if you want to factor r cosine plus r sine. So that's our polar form. And the reason why we're talking about polar form, because multiplication and division will be the easiest in polar form. And I'm going to talk about it now, how to multiply and divide. We discussed how to convert one form to another, and we did some practice in Delta Math. Now let's discuss about multiplication and division of complex numbers in polar form. You guys done? Mm-hmm. We're talking about multiplication and division of complex numbers in polar form. These formulas will not be given to you on the test, however, they're super simple. So let me write the formulas first. I'm not going to prove it. I'll just write them down and I'll show you how they work. Okay, let's say two numbers are given. Z1 is given in the form of R1, where R1 is a modulus, cosine theta 1 plus I sine theta 1. And Z2 will be given in the form R2 cosine some different angle, theta 2, plus I sine theta 2. Write this down, and I will give you two formulas, how to multiply and how to divide numbers in polar form. We're actually 2/3 done already with the notes. Maybe it will be even faster than 20 minutes. Then to multiply Z1 times Z2. So I told you that it will be very convenient to multiply the two numbers. Maybe anyone have any idea of what will happen? Go ahead.
R1 times R2 and then cosine theta 1 times cosine theta 2, cosine theta 1 times sine theta 2, and then cosine theta 2 times sine theta 1 cosine theta 2.
You have a very good idea. So what will happen, you're absolutely right about multiplying the moduluses, R1 times R2. For the angles will be added. So it will be cosine theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. And that's it. This is super simple to memorize. You will multiply the moduluses, you will add the angles. Super simple to memorize. No, none of my students had problems last year with that. And let's write formula for division, and I'll do a couple practice questions on that. Formula for division, and you might guess it. Z1 over Z2. Try to guess it. Go ahead. Yeah, go ahead.
So cosine of theta 2 minus theta 1.
Theta 1 minus theta 2.
Yes.
Okay.
Plus sine of theta 1 minus theta 2 over. Whoa.
No, you're right. You're right. So cosine of subtract the angles plus I sine subtract the angles. What happens with moduluses? Divide them. Yeah. Divide R1 over R2 and multiply by this business. Yeah. So very simple to memorize. When you multiply moduluses, add the angles. When you divide into complex numbers, divide the moduluses, subtract the angles. Will be pretty simple. Let's do two examples left and DeMoivres Theorem left. And we will be done. Maybe 5 minutes more? Let's do example on these two formulas. Example given z1 in the form of 2 cosine. No, let me change it. Let me do this. Let me do 24. Apologize for that. Let's do this. 24 cosine 300 plus I sine 300. Z2, 8 cosine 75 plus I sine 75. Let me find Z1 times Z2. And I would like to find what is Z1 over Z2. Just use these two formulas which we just discussed. Whenever you're ready, I'll scroll this up and I will show you. Or you can go ahead and start working on that and just check with me on the board. Scrolling it up. Z1 times Z2. So we have to multiply the moduluses. Will be 24 times 8 times. And what am I doing with the angles? Perfect. We add the angles. Cosine of 375 plus I sine 375. Make sure that these numbers are always the same, since you either add in both or subtract in both. These numbers they call the argument, they will always be the same. And you can simplify if you want to. This is what? 24 times 8. 160 plus 32, 192. Please check me. 160 plus, yes, 192 cosine. You can get the number if you want to. You can. I will just simplify. I know 360 the entire rotation. I'll subtract 360. I'll leave it as 15 degrees plus I sine 15 degrees. And yes, and you're absolutely right. If you want the numbers, you can just use a calculator and get these numbers and get it back to rectangular form. But since 15 is bad, you just leave it.
For I sine 15,
You put I, yeah. You put I because this is still part of this is still imaginary part of the number. One more example, one more theorem. 3 minutes left. Okay, wait, sorry about that. The division, yes, division now. So division I would like to find, you can go ahead and start working on that already. Z1 over Z2, divide the arguments.
Wait, question.
Yes.
We're going to be doing 300. Oh, yes, never mind.
Okay. So what is that? 24 divided by 8 cosine of 300 minus 75 plus I sine of 225. And these are good numbers. This is something which we can calculate without calculator. But you will have calculator on the test. So this should not be a problem whatsoever. Z1 over Z2, 3 cosine of 225. Can I get a radical? I know the 225 is right here and references to 45, but it has to have same side and cosine as 45, but negative. Negative. Is it?
No, negative root 6.
Why?
Cosine 225.
Yeah.
Yeah, negative root 1. You're right, first one.
I didn't say.
No, it's totally fine. Thank you for participating. I think, please check me. It looks like, so both should be minus root 2 over 2, right? Both negative. If you want to, you can stop there. I will be already happy with that if you get to this point on the benchmark. If you want to multiply by 3, you can absolutely do that. It will not really change much. Minus 3i root 2 over 2. So all I did, I just distributed from here, which is really not that necessary because this is already rectangular form. This is not necessary. If you want to do it, go ahead. If not, nothing will change to your grade. So this example is done. Last thing, 2 more minutes. DeMoivres Theorem. Not sure if I pronounce it correctly. That's called that's a French mathematician. DeMoivres Theorem. DeMoivres Theorem is about raising complex number to a power. Given z are the same form, cosine theta plus I sine theta. I would like to raise the z to the power of n. Your guess. Please guess what will happen with r. Go ahead.
Cosine n.
So you're saying cosine n?
Wait, whoa.
I'm trying to take z and raise the entire z to the nth power.
So r to the power of n.
R to the power of n, yes.
Cosine n.
Cosine n
Plus cosine sine.
Let me just give you a bit of hint. So cosine n times theta. Because it's actually very logical. When you multiply the numbers, you'll do theta 1 plus theta 2 plus theta 3 plus theta 4 and so forth. Well, there are n of them. So it will be cosine n times theta plus I sine n times theta. That's it. That's how to raise complex number to the nth power. It's very useful. Again, I'm not proving these formulas. If you can prove it to me at some point, I'll give you extra credit. Just don't have time to prove them. But I'll just state it. That's the formula. Will not be given to you on the test. But I think it's pretty self-explanatory. Not really. It's logical. That's called logical. You need to know this. You need to memorize it. I will not provide this formula on the test. And example, and we're done. Example would be to please take number z, which is 5 times cosine 15 degrees plus I sine 15 degrees. And please raise this entire number to the second power. I'll give you 30 seconds and then I'll write the answer and we'll be done.
I have a question.
Yes, ma'am?
Why can't we treat it like a plus b squared? Well, parentheses squared. Why can't we treat this like that?
A plus b squared. Because it's a polar form, it works a bit differently.
So rather than making cosine n times bigger, we just make angle theta n times bigger?
We make an angle n times bigger, yes.
And is this true for all polar coordinates?
All polar coordinates, yes. So what happens is 5 squared, if you did already, cosine I sine 15 times 2. Let me just put parentheses over here. I'm almost done. Just write the answer and I'm done. 25 cosine of 30 plus I sine 30. Just have to calculate. So on the test, if number is good, like 30, 60, 90, or 135, if number is something which you can calculate, you can do it. If you can't, you can leave it like that or just use a calculator and get a decimal. Whatever you do on the test with that, I'll be happy. 25, what's cosine 30? Thank you very much. And what's sine 30? You could stop there, or if you want, you can multiply by 25 and distribute. You can move on and say it's 25 root 3 over 2 plus 25i over 2. That's it, over. I'm going to stop the recording now.